In this video, we are discussing the asynchronous version of the electric potential lab. This lab is a little bit different compared to a lot of the others we do because it is pretty much entirely theoretical and is focusing much more on how you should start working through these problems as opposed to doing an experiment. So for this lab, you are being given two context-rich problems, which is the fancy physics way to say a story problem, where you are going to have to figure out what are the important bits of data, what are the not important bits of data, and work through that problem. In the lab procedure, we provide a structure of a way to work through these kinds of problems to help you parse that information, figure out what's important, and work through it. I understand that some of you who have a lot more experience doing this kind of thing might have your own systems and ways of doing this that you've worked up over time, and that is fine. What's important and why we have this is that it is important to have a structure, a method of attack to work through problems like this. So, for the sake of this lab, please use the provided structure so that we have kind of a common language of how to work through these things. And you can work through the problems with that structure. And over time, as you get more experience as a physicist, you might change the way you do things, but this should provide you with a solid start. Thank you for watching this video. Here's a fun fact. This is the birthday cake from ENIAC's 70th birthday party. ENIAC, the first universal computer built at the University of Pennsylvania Moore School of Electrical Engineering. It was such a computer marvel, it would only take 140,000 of them to store an MP3.